So in this video, we show you how in Excel to solve this problem of flipping a coin 20 times and counting the times that the run exceeds four or more. And we're going to do this in Excel. We're not actually going to flip real coins. We're going to show you how Excel can be a simulation tool. So if you can see right now, I've got a trial of 20. There's my 20 flips. And the first time I flipped it, I got a tails, and then I got a heads, and then I got a tails, and a heads, and the tails, and then another tails, and another tails. And if you look over here, I'm counting the runs. So when I'm alternating from tails, head, the run doesn't ever get past 1, but then I get a run of 3. And then I start over 1, get a run of 2, 1, 2, and then look at this. 1, 2, 3, 4, 5, 6. I got a 6 of run, which exceeds 4. So did I get greater than or equal to 4? Yes. So that particular run, I was successful. But what if I did it again? Just because I did it one time. So let's look at the formulas. Actually, let's not look at the formulas. Let's just understand. Yeah, let's look at the formulas. So these formulas that I've written in here, these are not hard-coded. It is a formula, and it's an if statement. And there's a lot of stuff working in there. First of all, I'm doing something using a RAND function. And the cool thing about a RAND function, it generates a random number. So that's that RAND function, and it gives me a number equally likely between 0 and 1. It's essentially calculating a probability, but it's always a probability equally likely between 0 and 1. I reference that, and I generate a random number, and if that random number is less than 0.5, I'm going to say, well, then that flip of a coin returns an H, or a heads. If it's greater than 0.5, it returns a tail. So I've got some tails when it's less than 0.5, and then sometimes it became a heads. But I'm not just looking at that, I'm looking at the runs. So I've also got another if statement that says if, so let's look closely at this. If the value in C4, so C4 is the current flip, in this case it's a head, if that equals what the previous flip was, which in this case it does, if it equals to heads, then it takes the current run, which is the number, the run, which is the number above it, D3 plus 1, so it adds ones to it. Otherwise, it resets it to 1. If this is not true, if they're not equal, that means it needs to reset and start back at 1. So you can see, since if I looked at this one, since they're not equal, I don't continue and make this 3. I don't increase 2 plus 1. I have to start back at 1. Okay, so that's just one experiment, one trial of 20 flips in a row. But I need to do this a whole bunch of times if I'm going to calculate a probability. So I've done that, and this is going to hurt your eyes a little bit, but just deal with it. I've done it 100 times. There's 1, here's 2, here's 3, and if I scroll all the way over to the right, I just keep copying and pasting, all the way to 100. And anytime I got a yes, like see in this case, the max run was 3, so I don't, these no's will be zeros. These yeses will be 1, so I've also got another row in there. So if it's a yes, I give it a 1. If it's a no, it's a 0. And I sum all of my yeses, and then I divide by 100. So the probability of a run of 4 or more out of 20 flips is around 87%. That's using data-driven modeling to help generate a probability. So if you think in meteorology, when they're running a bunch of different trials to figure out where a hurricane is going to land, we use simulation models to do a lot of things, but the primary purpose is to calculate a probability. We will start, we go more details of probabilities. You don't have to use this complex simulation model, but I wanted to give you a feel of how we can build simulation models within Excel to generate probabilities. Thank you.